immediately you see an alert. As soon as we just enable that thread, we get the complete alert with images of the incident type, car detected, the image, the target, at what time, and this is real time. See, you know what Palantir is, right?
Palantir and global surveillance.
Now imagine this, that power, that capability running on your laptop, no cloud, no billion-dollar contracts, no permissions. I built something similar, smaller, sharper, and shockingly effective. Introducing Sentry SAM. Local intelligence system that sees patterns others miss. And yes, it runs entirely on your machine. Let me open SAM Sentry. And here I have a video source. It's open, so if it was protected with credential, then you would need to pass the username and the password. And I want to detect, let's say phone in that stream, and every 20 seconds I want to get an alert over a Discord channel. So let's initiate this. As soon as I initiate, it connects to a webcam which is monitoring a parking lot. And right now it was supposed to detect phone, but there is no phone. So let's introduce a car and click on this update intent. See, immediately you see an alert. As soon as we just enable that thread, we get the complete alert with images of the incident type, car detected, the image, the target, at what time, and this is real time. See, as soon as it's detecting. So that's how simple it is actually, and you can anytime update it. It will keep safe here as long as you want. And now I'll just show you how you can get the webhook. You can come to any channel, click on the edit channel, integrations. You can go to webhook, create new webhook, and it's going to create one. Come here, copy webhook URL. That's it. That's all you have to do actually, and come here and paste it. Once you paste it, it's always saved forever. SAM Sentry isn't just an app, it's a multi-process orchestra conducting 3 programming simultaneously. So what you see here is just a cool UI where you can provide any live stream, maybe secured or unsecured access at TSP protocol link, or you can even provide, if you want to play around, you can also provide any live YouTube live stream as well. If you want to provide your webcam access, then you just have to put 0 over here instead of an URL. Then your physical webcam also can help. So depending upon the tag ID of your device, then this is the place where you'll actually define what is it that you think is an alert according to you. In any live stream, it could be physical location monitoring or security monitoring, like any weapon that you detect on a footage. So then the final thing is, this is where you will define what is where actually you want to do the alert. As soon as the SAM Sentry detect any of the threat that you have defined above. So for now, I am giving support for Discord. In future, I am going to add more and more. So here you have to just paste the webhook URL. I am going to tell you how you can get the Discord webhook URL for any channel that you would like to make. And after that, you just need to define one configuration, like how frequently you want us to give an update, of the live incident that it is capturing. So it can become overwhelming because in a scene, you would detect multiple instances very frequently. So just not to jam your alert, you can define here the update frequency of the alert, although the incident are recorded as soon as you see them. And then you just click on the initiate. So if I label it, this is 1, 2, 3, 4. In just simple 4 steps, you were able to configure a real-time monitoring application for free. No, anything, nothing leaves your device. Everything remains locally on your computer itself. And actually, I have open sourced the complete code. You can verify it. Second, I am actually going to give you a very detailed explanation of how it works. And yeah, that's pretty much, you can say, a new year present from my end. You will see live monitoring over here in this window. I'll also show you one demo when we are going to have gain the understanding of how everything is working. And here you are going to see the Intel stream logs, something important. Everything will be logged with the proper timestamp and all. So this is perfect. This is a high level overview how to use SAM, Sentry. And now what I want to do, give you an explanation of 3 tiers of tier 1, tier 2, and tier 3 explanation of the SAM. One second. Yeah, so let me zoom in here. So let me actually define for you what I mean. The tier 1 architecture. So the tier 1 is the web-based interface. It's built in Electron so that it can run on any platform. For now, I'm giving support for Apple Silicon, but in future release, I will be adding Windows and Linux as well. So it's a, it's a web-based interface that operates everything in the tier 2, in the tier 2 and in the tier 3. And but here's what makes this fascinating, because most apps pick one language and stick with it. In this project, Sentry, I deliberately split responsibility to play each platform strength. Electron handles this cool UI, Node.js manage the system level choreography, and Python unleashes the raw AI horsepower in this application. So let's start where the user interact is the front end, and let's understand a little bit more about how what are the things that are being working here. So this is not a typical web dashboard. It's designed like a tactical operating system. In keeping that in the mind, it is built with HTML, CSS, nothing fancy here. But the magic happens in the bridge.js file that I have built. What is happening here is there is this is where your UI comes alive. But the data flow both ways. The main process stream backs the real-time telemetry, this detection, confidence score, system health metrics. UI render all this at 60 FPS with that signature scaling aesthetic that right now you're seeing. So the centerpiece is the live MJPEG. If I believe that, so think of this as a streaming service, and a live MJPEG video streaming shows what AI sees overlaid with the bounding boxes around the direction thread. So when something dangerous is spotted, the entire HUD flashes red with the thread detected banner. It's functional and it looks kind of cinematic as well. You must have seen in the intro as well that I have just shown you. So the main process is the hero here. So you can call it the air traffic controller of everything. The first responsibility, the process management. So let me make you understand what is happening. So once when you launch this application, Sentry, when you launch this application, the main process spins the Python engine, and it works as a child process. So uh, and it babysits if the entire engine crashes, the main process detects it, logs will log the failures, and it can restart automatically. That's the idea was. The second one is the IPC protocol, IPC proxy, you can also say it. So when UI sends a command, let's say add a target, for example, a knife. Do we want to track in the visual if there's a knife is being used, maybe in some use cases. So the main process intercepts it and validates it, then forwards it into the Python using ZeroMQ. Uh, why ZeroMQ instead of standard IPC here? Because it's brutally fast and everything happens in sub-milliseconds latency for cross-process messaging, and that we really want that. I really want it to be really fast. It should not fail. Like the events are happening and you're still waiting it for processes to come over. The third is the telemetry gathering. The Python engine broadcasts Intel stream logs. It detects events, performs matrices over ZeroMQ socket. The main process subscribes to this particular stream, filters relevant data, and pipe it back to the UI. So this architecture means that the UI stays responsive even when the AI is maxing out on the GPU. So that's something we have to take care of. The main process act as a buffer, preventing Python heavy computation from backlogging the interface. So now we'll need to talk about the main process, you can say the brain as well, the neural engine here that we have developed. So where does the intelligence lives? So there are actually two AI models that works in tandem here. Actually, they are the vision models. One is the SAM3 segment anything model. This is the heavyweight champion. SAM3 performs zero shot semantic segmentation, meaning you can find all guns without training it on the gun images. So it understands the concept, not just the pixel. The precision is surgical, but it's computationally expensive. So this is the bottleneck. YOLO-World, the second model, is a lightweight backup when SAM3 is too slow or unavailable for certain devices. I really want this to actually work everywhere, even where the GPU is also not available. So this is where for some of the user, YOLO-World will kick in, and it's optimized for real-time detection with lower accuracy, although you compromise on the quality of the detection. Think of it as a difference between a sniper rifle and a shotgun. So the video capture run in its own thread, and it supports the webcam, RTSP security camera, even your YouTube live stream. Frames enter into a processing queue. The monitoring gap, the monitoring loop actually grabs the frame, feed it to active AI, along with the target concepts like weapon, intruder, fire. Waits for the prediction. When the match founds, two things happen simultaneously. Uh, First, the metadata, the bounding box confidence scores get published to ZeroMQ to this electron. The process frame with overlay gets encoded with the MJPEG and pushed into the internal Flask server. This dual streaming architecture means that UI gets the smooth. Oh, 1 second. UI gets the smooth playback and structured data without detection, without any bottleneck that we are creating. So here's the architecture diagram. Now the final is the alert system. The detection is only half of the battle. Response is what matters. So when target concept is detected above your confidence threshold says 85%, the alert pipeline triggers. Step 1, it takes the snapshot. The engine freezes the frame in the memory, and a Discord webhook posts the request, fires to your configured Discord server channel with rich embeddings like timestamp, thread type, and confidence score, and the snapshot as well. So you get the notification within seconds. And in the UI as well, we flash the red place alert sound, log the event in the Intel stream. So this multi-channel alerting means that you can walk away from your decks but stay informed whenever you are in another room or another building. So thread gets reported as soon as it happens. So this is an overall working. There is too much details to be uh, to be discussed, but for introductory, this is how it works. I really want you to visit the GitHub repository and read the implementation, although you can visit the GitHub repository. You'll see the complete source code is present over there and how you can run it locally. And also, if you are running the M4 Apple Silicon, then you can right away use the. So I hope you enjoyed that project. If you want me to do a code walkthrough of this project, which is very long, but I'll do that. If you want that, I'll can comment down. I'll explain you each code line by line how everything is working here, and that's how you build an enterprise grade software on your own. And the only limitation is the thinking here, because if you know the concepts, you can use an AI tool to work with you and get the desirable result. So I believe knowing this would be cool. So you have to develop the applications keeping in the mind that that can be used very easily, accessible for everyone, and I open source it for you. And thank you very much for watching this. I hope that you got inspired for learning to do some cool stuff with your imagination. Thank you.